In this section, we're going to look at complex rational expressions. A complex rational expression is an expression that contains rational expressions within its numerator and/or its denominator. So some examples of this would be like these three fractions I have here: x plus 5 over x in the numerator divided by 4x in the denominator. A fraction in the numerator, x minus y over x plus y, divided by 2x minus y over 3x plus y. And then another one would be like r over 6 plus r squared over 144 in the numerator. And then in the denominator, r over 12. As you can see, these look pretty weird. And so there's a way you can simplify them. And you can use some steps to do that. To simplify a complex rational expression, find the LCD of all the rational expressions within the complex rational expression. Multiply the complex rational expression by 1. Write 1 as the LCD divided by itself. So if you were to find the LCD to be like 144, then you'd multiply the numerator and the denominator by 144 divided by 144. Distribute and simplify so that the numerator and denominator of the complex rational expression are polynomials. Factor and, if possible, simplify. Let's give the first one a try. We have 7 over x squared minus 2 over x in the numerator, and in the denominator 7 over x cubed minus 2 over x squared. Now remember, with least common denominators, or in this case we could think of our denominators as the denominators of every fraction that is in the complex rational expression, as the numbers or factors that we need to look at to determine our LCD. Notice that we have x in all four denominators, and so we need to take the greatest number of times x appears. If we look at all four, we see that x to the third is the highest degree denominator, meaning that x appears the greatest number of times as 3. So we look at each individual denominator and then find our LCD based on that. Now that I have this LCD, I'm going to multiply the numerator's numerator by x to the third and the denominator's numerator by x to the third. Now you can see that x to the third over 1 divided by x to the third over 1 is equivalent to 1 if you were to reduce it. But my goal is to take that LCD and distribute it to the fractions in the numerator and in the denominator. I'm going to do this one time, and then from here on I'm just going to distribute it, and hopefully you all are following along with this. So I would have 7 times x cubed over x squared minus 2 times x cubed over x. That's the numerator. In the denominator, I'd have 7x cubed over x cubed minus 2x cubed over x squared. And now I can look at the powers and reduce out the common factors. The most obvious one is 7x cubed over x cubed. That just divides out. On the first fraction in the numerator, I have 7x cubed over x squared. So the x squareds will divide out and I'll just be left with 7x. I have 2x cubed over x, which will reduce out, and I'll be left with an x squared in the numerator. The 2 as well will stay. And then x cubed divided by x squared in the last term in the denominator. The 2 will just stay, it doesn't reduce, but the x cubed and the x squared reduce, and I'm just left with an x. Now I'm going to rewrite this. 7x minus 2x squared all over 7 minus 2x. Notice that this is not maybe quite done. We could factor out an x still in the numerator, So we have 7 minus 2x over 7 minus 2x. So the only thing that I'm left with is an actual x. So see how much reduced? It's, you'd never know that to just look at it, but once you reduce it, it simplifies very nicely. Now my goal for you is to get to the point where you can just mentally distribute that LCD through and reduce those fractions without having to write this step here. This is what you need to be working to skip. If you have to write this out every time, the part that I just put in the cloud, it's going to take too much time to reduce these. You need to be able to distribute it and write it from this step up here down to this reduced step. Your goal is to get rid of those denominators. Let's try this again. I'm going to highlight the denominators that we have in both the numerator and the denominator. The two denominators we have to look at are 3x and 9x. Since 3 is a factor of 9, I'm going to take 3 times 3, which is the 9, and x only appears one time in each. If I look at this complex rational expression, I can see that if I multiply the numerator by 9x over 1 and the denominator by 9x over 1, I am multiplying by a funny looking 1. I'm going to distribute that LCD to both terms in my numerator and both terms in my denominator. This is the step where I'm telling you, you've got to practice this. 9x times 1 will give me 9x minus, and now remember, 9x divided by 3x will just be a 3. So I'll have minus 2 times 3. Now let's go to the denominator. So in the denominator, I have 9x times x. That will give me a 9x squared. And in the denominator, I also have to distribute the 9x to 4 over 9x. That will give me a minus 4. I'll rewrite this. I have 9x minus 6 over 9x squared minus 4. I can factor the numerator by factoring out a 3, and I'll be left with a 3x minus 2. In the denominator, this is a difference of squares. So this will factor to 3x plus 2 and 3x minus 2. That's great because now my 3x minus 2 binomials divide out, and my final answer is 3 over 3x plus 2.